Hi everyone, in this video we are going to discuss about how to calculate the inradius and the area of the pedal triangle of an original triangle. Let's suppose we have a triangle like this, triangle ABC, where the side length BC is denoted by lowercase a units, side length AC is denoted by lowercase b units, and side length AB is denoted by lowercase c units. And also the angle BAC is denoted by uppercase A, you can assume it is in radian, and then angle ABC is denoted by uppercase B radian, and angle ACB is denoted by uppercase C radian. And also let's assume that the circumradius of this triangle is uppercase R units. Next we are going to draw the altitudes of this triangle. From each of the vertices we are going to drop a perpendicular onto the opposite side, and let's assume that those are the three altitudes and their point of intersection would be called the orthocenter, which is usually denoted by uppercase H. And the points D, E and F, they are actually known as feet of perpendiculars. That means they are the points where the perpendicular drawn from the vertices land on the opposite side. Now if we join the feet of perpendiculars, that will form the pedal triangle. And let's assume that the pedal triangle is the yellow triangle here, which is triangle DEF. And this is the pedal triangle of our original triangle ABC. I have already created a separate video on the pedal triangle where I have derived the interior angles of a pedal triangle, the side lengths of a pedal triangle, the circumradius of a pedal triangle. Now in this video I am going to derive the inradius of a pedal triangle and the area of a pedal triangle. I have shared the link of that video in the description, feel free to watch it. And if you watch that video, you will notice that for a pedal triangle, the interior angles are kind of like this. Angle FDE will be equal to pi minus 2 times A, angle DEF will be equal to pi minus 2 times B, and angle EFD will be equal to pi minus 2 times C. And also from that video you will see that the side length of this pedal triangle would be like this. FD is equal to R times sine of 2 times B, and also it is equal to B times cosine of B. Similarly, the side length DE will be equal to R times sine of 2 times C, which is also equal to C times cosine of C. And the side length EF will be equal to R times sine of 2 times A, which is also equal to A times cosine of A. In this video, we are going to use this information to calculate the inradius of the pedal triangle and also to calculate the area of the pedal triangle. So let's first calculate the area of this pedal triangle. We know that for any triangle, the area will be equal to half into the product of any two sides times the sine ratio of the angle contained between those two sides. If we use delta sub p to denote the area of the pedal triangle, of course not the original triangle, here we are talking about the area of the pedal triangle, and if we use delta sub p to denote the area of the pedal triangle, then we can write it as half times the product of any two sides. So we can say FD times DE times the sine ratio of the angle contained between these two sides. And now let's substitute the values here. So this should be half times. For FD I am going to use R times sine of 2B, and for DE I am going to use R times sine of 2C, and then for sine of angle FDE I am going to say this is sine of pi minus 2A. So this can be written as R square over 2 times we have sine of 2B and then sine of 2C, and then sine of pi minus 2A is equal to sine of 2A, because sine ratio of pi minus any angle is equal to sine ratio of that angle. So here I am going to write sine of 2A, and if we rearrange this a little bit, we can write it as R square over 2 times sine of 2A times sine of 2B times sine of 2C. So this is one of the formula for the area of the pedal triangle. Now I am going to again derive another formula for the area of the pedal triangle using the other values of the three sides. So for example, if we say delta sub P is equal to half times FD times DE times sine of angle FDE, and this can be written as half times what is FD? Well, if we scroll up a little bit, we are going to see that FD is actually B times cosine of B. So we can say this is actually B times cosine of B, and DE is actually C times cosine of C, times we have sine of this angle, which is actually pi minus 2A. And from here, can we write it like this? We can say this is equal to B times C over 2, so that would be BC over 2 times cosine of B times cosine of c times sine of pi minus 2a can be written as sine of 2a, and from here let's expand sine of 2a in terms of sine of a and cosine of a, so we can write it as bc over 2 times cosine of b times cosine of c times sine of 2a can be written as 2 times sine of a cosine of a, and from here you see this 2 right here and this 2 right here, they will cancel out each other, so we are going to be left with bc times cosine of b times cosine of c times sine of a times cosine of a. And from the sine law, we know that a over sine a is equal to 2 times the circumradius, and from here we can say then sine a is equal to a over 2r. So in place of sine a, I am going to use that value a over 2r. So then this is going to look like bc times cosine of a times cosine of b times cosine of c, and then in place of sine of a, I am going to use a over 2r. Now we have to clearly understand what is a. A is actually one of the side length of the original triangle, and r is the circumradius of the original triangle, right? And from here let's convert this a little bit. So here we can say this is actually a times b times c over 2r times cosine of a times cosine of b times cosine of c. Also we know that for any triangle, area is equal to a times b times c over 4r. I have already proved that in a previous video. I have provided the link in the description. Feel free to watch that video. So we know that area of any triangle, if we think about the original triangle here, that can be written as a times b times c over 4 times r. So then in place of a times b times c over r, I am going to use 4 times delta, and that delta is the area of the original triangle. So from here we can then say that this is actually equal to a times b times c over r times 1/2. So I am writing it in front of it, and then times cosine of a times cosine of b times cosine of c, and from here we are going to write it as half times 4 times delta. Now this delta is the area of the original triangle times cosine of a times cosine of b times cosine of c, and from here we can write it as 2 times delta. This delta again is the area of the original triangle, and times cosine of a times cosine of b and times cosine of c. Now you see the area of the pedal triangle has been expressed in terms of everything about the original triangle. Here the delta is the area of the original triangle. Angle a, b and c, they are the angles of the original triangle. So everything is expressed in terms of the original triangle, but this is actually the area of the pedal triangle. So here we can say that the area of the pedal triangle, so let me quickly write here on the left hand side, the delta sub p, that is the area of the pedal triangle, is actually equal to 2 times delta times cosine of a times cosine of b times cosine of c. So far we have seen 2 formulae for the area of the pedal triangle. This is one of them, and the other one was up above, which is r squared over 2 times sine of 2a times sine of 2b times sine of 2c. So those are the 2 formulae for the area of the pedal triangle. Now let's try to calculate the inradius of the pedal triangle. I have already created another video where I have proved that the area of any triangle can be expressed as the product of the inradius and the semi-perimeter. So essentially what I am saying here is that area of any triangle can be expressed as a product of the inradius and the semi-perimeter, which is essentially equal to lowercase r, which is usually used to denote the inradius, and times lowercase s, which is usually used to denote the semi-perimeter. Now let's first try to find out the semi-perimeter of the pedal triangle. Now what would be the perimeter of the pedal triangle? We have to add up the 3 sides, so that would be FD plus DE plus EF, and that will be equal to r times sine of 2b plus r times sine of 2c plus r times sine of 2a, and this can be written as r times sine of 2b plus sine of 2c plus sine of 2a, and this can be written as r times, when a plus b plus c is equal to 180 degree or pi radian, then sine of 2a plus sine of 2b plus sine of 2c is actually equal to 4 times sine of a times sine of b times sine of c. I have already created a separate video on that. Feel free to watch it. I have shared the link in the description. So here I am going to write 4 times sine of a times sine of b times sine of c. and we can then write it as 4 times r times sine of a times sine of b times sine of c. So what would be the semi-perimeter then? If I denote that as S sub p, which is the semi-perimeter of the pedal triangle, that will be equal to half of this quantity, and that is essentially equal to 2 times r times sine of a times sine of b times sine of c. So that is the semi-perimeter of the pedal triangle, and we have already calculated the area of the pedal triangle. So now we can easily calculate the inradius of the pedal triangle. Now the inradius will be like this. If I denote that by lowercase r subscript p, so r sub p to indicate that this is the inradius of the pedal triangle, that will be equal to area of the pedal triangle over the semi-perimeter of the pedal triangle, because up there you can see that inradius is equal to area over the semi-perimeter, and that's exactly what I am going to use here. So the inradius of the pedal triangle can be denoted as area of the pedal triangle over the semi-perimeter of the pedal triangle. And what was the area of the pedal triangle? Well, we have seen that the area of the pedal triangle was r squared over 2 times sine of 2a times sine of 2b times sine of 2c over the semi-perimeter of the pedal triangle that we have just calculated, that is actually 2 times r times sine of a times sine of b times sine of c. And if we simplify this, we can say that we are going to have r in the numerator, because 1 r in the denominator will take out 1 r from the numerator, so we are going to be left with just a single r, and then we have 1/2 in the numerator and another 2 in the denominator, so that will be 4. So that would be r over 4 times sine of 2a times sine of 2b times sine of 2c. I am going to expand them, so I am going to write them like this. Sine of 2a can be written as 2 times sine of a times cosine of a, and similarly sine of 2b can be written as 2 times sine of b times cosine of b, and then sine of 2c can be written as 2 times sine of c times cosine of c, and over we have sine of a times sine of b times sine of c. Now if you carefully look at it, this sine of a will cancel the sine of a, the sine of b will cancel the sine of b, and sine of c will cancel the sine of c, and this 4 will be cancelled by this 2 and one more 2. So we are going to be left with just 1 2 right there. So that would be 2r times cosine of a times cosine of b times cosine of c, and that is the formula for the inradius of the pedal triangle. And here again you see everything is expressed in terms of the original triangle. Here we have the circumradius of the original triangle and the 3 interior angles of the original triangle. So if we know some information about the original triangle, we should be able to calculate the inradius of the pedal triangle. So we have been able to calculate the area of the pedal triangle and the inradius of the pedal triangle. Next we are going to take an example. Let's suppose we have an example like this. ABC is an equilateral triangle. That means all sides are of equal length and each angle would be 60 degree or pi over 3. Side length has been given as 6 cm. We have to find the inradius and the area of its pedal triangle. So we have been provided with what kind of information? We know that A is equal to B is equal to C because it is an equilateral triangle. So we can say they all are of equal length, and that has been provided as 6 cm. And also the angles will be of equal size. So we can say A is equal to B is equal to C is equal to 60 degree, or you can also denote it as pi over 3 radian. Now what is the formula for the inradius of its pedal triangle? Well, we have just seen that the inradius of the pedal triangle is actually 2 times r times cosine of A times cosine of B times cosine of C. Here we have to somehow figure out the circumradius of the original triangle, right? So what would be the circumradius of the original triangle? Well, that will be equal to A times B times C over 4 times delta. Now here uppercase R is the circumradius of the original triangle, which is in this case the triangle ABC, and delta is the area of the triangle ABC. So now let's do a quick little calculation here. What would be the area of the triangle ABC? Well, because it is an equilateral triangle, we know that the area of an equilateral triangle is actually equal to square root of 3 over 4 times the side length squared. So let me calculate the area on the side here. So area of the triangle ABC will be equal to square root of 3 over 4 times the side length squared, so in this case 6 squared, and that will be equal to 9 square root of 3, and since this is area, of course it will be centimeter squared. And so what will be the value of R? Well, that will be equal to A times B times C. In this case this is 6 times 6 times 6 over 4 times delta, that is 4 times 9 times square root of 3, and that will be equal to 6 over square root of 3, so that will be equal to 2 times square root of 3. Now that we know the value of uppercase R, which is the circumradius of the given triangle, then we can easily calculate the inradius of the pedal triangle. So from here we can say then the inradius of the pedal triangle will be equal to 2 times R. What is R? Well, R is actually 2 times square root of 3 times cosine of A, so that is cosine of 60 degree, times cosine of B, that is also 60 degree, and times cosine of C, that is also 60 degree, and that is essentially equal to 4 times square root of 3 times cosine of 60 degree is actually equal to 1/2, so that would be 4 times square root of 3 times 1/2 times another 1/2 times another 1/2, and that is actually equal to square root of 3 over 2, and the unit of course will be centimeter because we are talking about inradius of the pedal triangle. So that is the value of the inradius of the pedal triangle. Now let's quickly calculate the area. So area of the pedal triangle is equal to 2 times delta times cosine of A times cosine of B times cosine of C, and let's plug in the values here. So that would be 2 times delta is actually the area of the given triangle, and that is 9 times square root of 3 times again 1/2 times 1/2 times 1/2, because cosine of A is actually equal to cosine of 60 degree, which is 1/2. Similarly cosine of B also will be cosine of 60 degree, and cosine of C is also cosine of 60 degree, so that will be 1/2 times 1/2 times 1/2, and that will be equal to 9 times square root of 3 over 4. And since this is the area of the pedal triangle, the unit would be centimeter square. So we have been able to calculate the inradius of the pedal triangle as well as the area of the pedal triangle for the given triangle ABC, where it was an equilateral triangle with a side length of 6 cm. So here the inradius of the pedal triangle turned out to be square root of 3 over 2 cm, and the area of the pedal triangle turned out to be 9 times square root of 3 over 4 cm squared. I hope everything made sense. Thank you for watching. See you in the next video.